Today we're going to take a look at some more from section 6.1. And today we're going to look more specifically at linear and angular speed. All right, so let's start with some definitions. So angular speed is exactly what you think. It's the speed at which the angle is rotating. So angular speed is not how far something's traveling, it's how fast is it spinning or how fast is it rotating. Okay, so to find, or the formula for angular speed is just how fast or how big is the angle divided by time, right? So one of the things we have to make sure of is that we take that angle and it's got to be in radians and divide by time. Okay, the symbol for angular speed is this funky looking W, which is actually the Greek letter omega. So it's the letter omega. You can make it look like a W. I'm okay. You don't have to make it fancy like that. But the one thing we need to remember about our units, right? Units are super important. Yesterday we talked about arc length, which is a length, so inches, feet, miles, etc. Then we talked about area, which is inches squared, feet squared, etc. So today we're talking about a radian divided by time. So our units are going to be something like radians per second, maybe radians per minute. Okay, sometimes because of that angle, it'll ask you for revolutions per second or revolutions per minute, or possibly degrees per unit of time. And we're going to have to do some conversions, which we'll see in some of the examples over the next couple days. Okay, so linear or angular speed is the speed at which the angle is spinning or the angle is rotating. Okay, and the unit normally is radians per second, radians per minute, etc. All right, so take a look at the first example. A record is spinning 12 times per second. Find its angular speed. Okay, and we're going to talk about radians per second. So it specifically tells us what our units are going to be. So I know my final answer has to be in radians per second. All right, so we know that angular speed is equal to the angle divided by time. Okay, so let's talk about that angle. It doesn't tell us what the angle is, but it does tell us that it rotates 12 times. So if we think about one full rotation, we know one rotation is equal to 2 pi. So if it's spinning 12 times, I have to take 12 times 2 pi to figure out that angle, right? One revolution or one rotation is 2 pi, 2 would be 4 pi, 12 of those around would be 24 pi. Okay, and then the time, it says per second, so I just have 1 second on the bottom. So again, I know my angle is now in radians because I took that 12 rotations or 12 times around multiplied by 2 pi, so that's in radians. And if I multiply, that gives me 24 pi radians per second. Okay, now if I wanted to find a decimal approximation, I would just take 24 and multiply by pi and round it to 2 decimal places. That would give me 75.40 radians per second. So again, both of those answers are acceptable. The first answer is exact, and the second answer would be that approximation. So we're just typing 24 times pi into our calculator. All right, so the next example says an object is traveling around a circle whose radius is 4 feet. Find the angular speed, and again, it tells us it wants radians per second, if it rotates 150 degrees in 10 seconds. Okay, so again, when I use the formula for angular speed, omega is equal to theta over time. But remember that theta has to be in radians. So the first thing I want to do is I want to take that 150 degrees and I want to multiply by pi over 180. Okay, that's also on our unit circle. So that would be 5 pi over 6 if I reduce it, 5 pi over 6 radians. So we eliminated the degrees and we turned it into just radians. So when we go to our formula, we don't want to plug in 150 up on top. We don't want to use that 150 degrees. We want to use that 5 pi over 6. And what was the time? The time was 10 seconds. Well, I know that's the same as 5 pi over 6 times 1/10, right? Because I could make this down the bottom over 1. So I multiply by the reciprocal. So my final answer here would be 5 pi over 60. And again, that's radians per second. It asked us for radians per second. My units are radians per second. That can be reduced. So we can reduce it to pi over 12. but otherwise we are good. We've got pi over 12 radians per second. And again, if I wanted to plug it into my calculator, it would be approximately 0.26 radians per second. In your homework, you're going to be asked to do both. Leave it as exact. So remember, pi over 12 is exact, and then 0.26 is my approximation. All right, so let's talk now about linear speed. So linear speed is probably the speed that you're more familiar with. It's distance over time. Okay, so if I'm talking about a circle and I'm talking about the distance that something travels is just arc length. Okay, so arc length is s. So we're going to take the distance and we're going to divide by time. Okay, our units are always going to be distance divided by time. Okay, so it's going to be something like miles per hour, feet per second, or something to that effect. Okay, so let's talk about the most common formula that I have written off to the side. Okay, so if I take this formula on the left, I know V is equal to arc length divided by time, right? It's the distance divided by time. Well, yesterday we said that distance is r times theta, right? The arc length is r times theta divided by time. Okay, and if I go ahead and I kind of pull this fraction out right here, that's the same as r times theta over t. And we just talked about that this theta over t is just our angular speed. So another formula for linear speed is just r times omega. Okay, so again, our omega's got to make sure, we've got to make sure that that angle is in radians per time. So that angular speed has to be in radians per time. And then we're just going to multiply that by our radius. So there are two different formulas. I will tell you that we will most often use this one right here. And in order to use that formula, we have to find the angular speed first. Okay, so we're going to sometimes have to do, kind of two problems in one in order to find the linear speed. We've got to find the angular speed first. Sometimes you might be told that. Sometimes you might have to find that. All right, so let's take a look at the next example. It says the typical diameter of a car tire is 20.832 inches, and that includes the rubber on the outside. If your car's computer knows that your tires are spinning at 161.36 RPM, which remember is rotations or revolutions per minute, what is the speed display on the speedometer? Okay, so remember your speed on your speedometer is going to be miles per hour. So I know that we're looking for our linear speed. We're looking for V. Okay, however, it does tell us that our tires are spinning 161.36 rotations or revolutions per minute. So eventually I'm going to have to do the radius times the angular speed. But before I do that, I've got to figure out my angular speed. Okay, so it tells me that it's going 161.36 revolutions per minute, right? So in 1 minute, it goes around 161.36 times. However, our W or our omega has got to be in radians per minute. So we've got to do some multiplication and we've got to kind of get rid of that revolutions. So in order to eliminate that revolutions, we have to put revolutions in the denominator. And we want radians, because remember, we want radians per minute to be our final answer. So what do we know about revolutions and radians? Well, we just talked about the fact that 1 revolution is 2 pi radians. So what we're going to have to do is we're going to have to take that 161.36 and multiply by 2 pi. That gets our revolutions to reduce, and then our final units are radians on top and minutes on bottom. Okay, so when I do that, that gives me 322.72 pi. So I'm taking that 161.36, multiplying by 2, and then leaving the pi at the end. So my angular speed, or my omega, is that 322.72 pi. So all I have to do now is I have to go back to this formula. I know the radius. I know the angular speed now. The only downside, it says the diameter is 20.832, so I've got to cut that in half. So that gives me 10.416. And then I'm going to multiply it by the angular speed, which is 322.72 pi. Okay, remember linear speed is going to be distance over time. So when I'm talking about my units have to be distance over time. Well, my distance in this problem was inches. So I know it's going to be inches on top. And then remember my angular speed was in minutes. So I know it's going to be inches in minutes. So when I take the 10.416 and I multiply by 322.72 pi, that gives me 3,061.45 pi inches per minute. Okay, but if you look back at the problem, it says round to the nearest mile per hour. So here's where some of those chemistry or physics conversions are going to come in handy. I've got to take that 3,361.45 pi, and again, right now that's in inches per minute. We've got to do a bunch of conversions, and we've got to change that to miles per hour. Okay, so let's talk about the minutes first, and realistically, it doesn't matter which one you start with. Well, I need to change minutes to hours. Okay, so we've got to put minutes up in the top, and we've got to put hours down in the bottom, and this way our minutes will reduce. Okay, so what do we know about minutes and hours? I'm pretty confident that 1 hour is 60 minutes. So we're going to have to multiply that number on the left by 60. Okay, now I've got to get rid of the inches. So that means I'm going to have to put inches down in the bottom. Okay, so what do I know about inches? I can go inches to feet. I know that 1 foot is 12 inches. So right now my units remaining are feet on top and hours on the bottom. But I don't want feet, I want hours. I want miles per hour. So now I've got to go ahead and I've got to get rid of this feet. So that means I need to put feet down in the denominator so that they will reduce. And I want to switch it to miles. Okay, so this one might not be one that you know off the top of your head, but 1 mile is 5,280 feet. So you may want to write that off maybe at the top of your notes. We'll use that conversion quite often because usually when we talk about speed, we want to know miles per hour. That's the speed that makes sense to us. All right, so now this is just one big fraction, and we remember when we multiply fractions, we multiply straight across the top. So we're going to have to take this 3361.45, multiply it by 60, and then 1, and then divide by the denominator, which is a 12 and a 5280. The one thing you've got to be careful in your calculator with is when you type this in, you're going to type in 3361.45, leave the pi off for now. You're going to multiply by 60. Okay, you're going to hit enter. So you're going to get a number. And then when you hit the division, you've got to divide by 12 times 5280 in parentheses. All right, so I'm going to go to my calculator. I'm going to type in 3361.45 times 60. I hit enter. I divide by, in parentheses, 12 times 5280. That gives me 3.18 approximately. 3.18 pi. And again, that's miles per hour. We can just do MPH if you want. Or if I want to actually multiply that by the pi, it's approximately 10 miles per hour. Okay, so be careful with your calculator. Please make sure you try these on your calculator to make sure we're getting the same answer. And if you have any calculator questions, be sure to ask in class. All right, example 4 says a point on the rim of a 6-foot diameter wheel is traveling at 75 feet per second. So here's the first thing is we're given 75 feet per second. Okay, we know that that right there is a distance over time. So that 75 feet per second is actually my linear speed, right? That's the v. Okay, we're also told that the diameter is 6 inches of the rim of the wheel. So we know that our radius is 3 inches. So right now we know v is 75, the linear speed is 75, and we know the radius is 6. What is it asking us for? It's asking us for the angular speed of the wheel in radians per second. Okay, so one of the formulas that we know, and again, it's the one I said we're going to use most often, is v equals r times omega, or linear speed equals the radius times the angular speed. All right, let's plug in what we know. So I know the linear speed is 75. I know my radius is 3. Okay, but we have a small problem here because my radius is 3 inches, but my linear speed is in feet. So I really cannot plug in that 3. I've got to make sure my units are the same. Okay, so what we're going to have to do is we're going to have to change this to feet. Okay, so I know my radius is 3 inches, but in order to use this formula, I've got to change my inches to feet. So that means I need to put inches in the bottom so that those will reduce, and feet in the top, which gives me 1 foot and 12 inches. So I know my radius is really 1/4 or 0.25 of a foot. So I've got to be really careful here. I can't just plug in that 3 inches. If I'm given inches and feet per second, I've got to change one of them. All right, so in this case, I chose to change the inches. You could have also changed the 75 feet per second into inches per second if you wanted. All right, so now that I have feet, I can go ahead and plug in that 1/4 times the angular speed. Okay, so what do I have to do? I have to take my calculator and I've got to do 75 divided by, in parentheses, 1/4, or divide by 0.25. And that gives me my angular speed is 300. Okay, so again, we've got to be really careful with our units. We know angular speed is always radians over time. So I know that when I divide by that 1/4, I am left with radians over time. And in this particular problem, my time was seconds, so I know that it's radians per second. Notice there was no pi in the problem at all because it said 75 feet per second. It wasn't 75 pi, it was just 75. So even though we don't have a pi in our answer, that's okay. Linear speed or angular speed does not necessarily have to have a pi. So we've got our angular speed is 300 radians per second. Okay, so again, please be very careful with your units. All right, last example. It says an object is traveling around a circle with a diameter of 10 inches. And it says if it takes 20 seconds, or if in 20 seconds the central angle rotates 1/3 of a radian, find the following. All right, so first of all, one of the things I see is I see the word diameter. Well, I don't want diameter, but I know the radius is half the diameter, so I know my radius is 5 inches. Okay. It also tells us in 20 seconds, the central angle rotates 1/3 radian. So let's think about what that gives us. That gives us a time and an angle. Well, remember, the first question says, find the angular speed. So the angular speed is what is the angle in radians divided by time? Well, it told us that it went 1/3 radian in 20 seconds. So I know my angular speed is just 1/3 radian divided by 20 seconds. And if I take 1/3 and divide by 20, I could put that as 20 over 1. So that's really 1/3 times 1/20th, which gives me 1/60. And again, my angle has to be in radians, and our time this time was in seconds. So there's my angular speed. Okay, next one says find the linear speed, and it says in inches per second. The last one did say radians per second, which is what we had. All right, so linear speed is V equals R times omega, or V equals R times the angular speed. Well, the nice thing is we just found the angular speed in part 1, or part A. So I've got to take that 5-inch radius, and I've got to multiply by 1/60. When I do that, that gives me 1/12, and that's inches, right? Because my radius was in inches. My time was in seconds, which is exactly what they told me they want the answer in. So there's my solution right there. Okay, again, it doesn't have a pi in it because way back in the beginning, it was just 1/3 of a radian, not 1/3 of a circle, 1/3 of a radian. It gave me that angle measure right away. All right, so the last question says, take that linear speed that you found in part B, but switch it into miles per hour, right? Inches per second doesn't mean a whole lot to you. So I want to take 1/12 inches per second, and I want to change it to miles per hour. Okay, so the first thing, we're going to have to do some manipulation or some multiplying of our units. So the first thing I'm going to look at is I'm going to look at the time. So I'm going to have seconds on the bottom. I got to get it to hours. Okay, but I know how to go from seconds, which I want to put up in the top, unfortunately, just to minutes, right? We don't necessarily know how many seconds are in an hour. I'm going to go seconds to minutes first. You may know how many seconds are in an hour, and that's fine. You could make that switch then as well. All right, so I know that there are 60 seconds in 1 minute. Okay, so now my seconds have been reduced. Right now my answer is in inches per minute if I was to multiply through. All right, so now I have minutes down in the bottom, so that means I need to put minutes up in the top. And I want to eventually get to hours, and that's good because I know that 1 hour is 60 minutes. Okay, so now my time in the bottom is hours, and that's what I want. I want my final answer to have hours in the bottom and miles up top. So let's go back to our distance. I have inches, so I need to put inches down in the bottom. So I'm going to put, inches down in the bottom. And I know I can easily switch inches into feet. And I know that 1 foot is 12 inches. So now I've got feet over hours, but I got to go one step further. And I know this takes a little while. I've got to get rid of feet, so I've got to put feet down in the bottom. So feet goes down in the bottom and miles goes up on top. And I know that 1 mile is 5,280 feet. All right, so finally I have miles up on top and hours down on the bottom. Everything else has reduced with the inches there and then the feet with the feet. I tried to do it in colored so you can see it pretty easily. So we're left with miles per hour. All I've got to do now is multiply across the top. So I've got 60 times 60. I hit equals. That's 3,600. I've got to divide by, in parentheses, 12 times 1, which you don't really have to do, times 12 times 5280. That gives me a decimal of 0.0047. I'm going to go ahead and hit math, enter, enter. And that gives me 5 over 1,056 miles per hour. Okay, again, that was not very fast. That was approximately 0.0047 miles per hour. If we were talking about, the actual speed rounded. So again, that object is not traveling very fast, but we could either leave it as an exact answer, the 5 over 1056, by hitting math, enter, enter, or the rounded. And that's all we got for today.